Keeper 3.6, the alternating series test. All right, so the alternating series test you basically use when you have a sign that's going back and forth, so like plus, minus, or minus, plus, minus, plus. Your alternating series will definitely converge as long as the limit equals 0 and as long as it's decreasing. And remember, decreasing not for the entire function, but decreasing over time. All right, so our first example, we have the sum as n equals 0 goes to, or n equals 1 goes to infinity of -1 to the n minus 1 over 7 plus 2n. So the first thing I'm going to do is I'm going to check the limit of the absolute value of the series. And I want to make sure that limit equals 0. So I'm going to do the limit as n approaches infinity of 1 over 7 plus 2n. If I plug in infinity, I get 1 over infinity, which is 0. So the first condition of the alternating series test is met. The second thing I'm going to do is show that it decreases over time. Now again, remember, I can either take the derivative or I can show that the term that I'm on is greater than the next. And so for this one, I'm going to show that the term that I'm on is greater than the next. So I'm going to start with n being the term that I'm on, and the next is n plus 1. So n is less than n plus 1. And now I'm going to build my series. So I have 2n is less than 2n plus 1. 7 plus 2n is less than 7 plus 2n plus 1. And then when I flip it to a fraction, I get 1 over 7 plus 2n is greater than 1 over 7 plus 2n plus 1. And so that tells me that this series is decreasing. And so since those two conditions are met, I know the series is convergent by the alternating series test. Example 2, we're going to do it the same exact way since it is an alternating series, since I have the -1 to the n plus 6. So the very first thing I'm going to do is I'm going to find my limit. So the limit as n approaches infinity of n over n squared plus 9 is 0. And next I'm going to show that it is decreasing. And this time I'm going to use the derivative, or find the derivative, to show that it's negative. So I have the derivative of n over n squared plus 9. I have to use quotient rule. So I have low d high minus high d low over low low. If I clean that up, I get negative n squared plus 9 over n squared plus 9 squared. This is a decreasing series for everything greater than 3. Even though my series starts at 0, I know for everything else greater than 3 is going to be decreasing. That means it's decreasing over time. So that tells me, since the limit is 0 and my series is decreasing over time, the series will converge by the alternating series test. All right, so next one, we're going to find the limit to start. So we have the limit is of n squared over n squared plus 5, which equals 1. It does not equal 0, so we cannot use the alternating series test. Now, anytime you can't use the alternating series test, you want to go ahead and use the divergence test. The divergence test will prove that it diverges. All right, so basically, to use the divergence test, I'm going to show the limit from n being even is 1, and then the limit as n approaches infinity of n being odd is -1. 1 doesn't equal -1, and neither one of those equals 0, so that means this series diverges by the divergence test. So once again, if your alternating series test fails, always revert to the divergence test, and your divergence test will work. Your divergence test will prove that it diverges because your limit doesn't equal 0.